We are Team A, and this is the Drunken Sailor. The goal for this robot is to actuate breakers, valves, and spigots to specified states based on input from a given mission file on a simulated cargo ship. Our approach to achieve this is using a 3D printer inspired gantry design. Based on the input from the camera, we can move our end effector to the appropriate location using a Cartesian stepper motor platform. Controlling the gantry system is an SKR 2.0, which is a board commonly used on 3D printers, and it runs to Marlin firmware. With this board, we can simply send the board coordinates over serial, and the end effector will move to these coordinates. It also allows us to home each axis without a limit switch using current sensing. The end effector has a linear actuator controlled pivot that rotates the finger 90 degrees so that it can actuate the spigots that are perpendicular to the robot. This linear actuator also gives us that extra oomph when flipping breakers. The end effector is attached to a drawbridge mechanism that lifts and retracts the end effector so the robot stays within the specified size constraints. For the motor control, we are using 4 12-volt DC motors with encoders mated to Mechatronics wheels. With our script, we can simply input a desired velocity and direction for each wheel, and the controller will do the rest. For perception, we use the Intel RealSense D435 depth camera to see our environment. The robot uses a YOLO neural network to identify the valves and breakers in front of it, and then gathers more information about its current position and state. And lastly, Ducky the pirate watches over our robot for good luck. At the beginning of the competition, the robot starts at a measured point on the testbed facing the wall. Then when the mission file is inputted into the algorithm, the robot homes all of its axes and moves towards the first station. Using our patent-pending slam technique, the robot drives into the wall to position itself directly in front of the objective. Each station location is pre-programmed into the Dead Reckoning path planning algorithm. Once the robot arrives at a station, it uses a RealSense camera to orient itself with whatever task it needs to accomplish. For instance, for the breaker, it detects its state, finds the center, then uses the end effector to flip the switch. For valves, the gantry system moves the end effector in a predetermined path to open or close it depending on its state. For spigots, the end effector moves in an arc shape to rotate the wheels. Lastly, for one of our coolness factors, we have a speaker inside the robot to play tunes as it traverses the course. Overall, the robot achieves the goals we set at the beginning of the semester and meets the ShipBot specifications. If we were to redo the robot, the main thing we would improve is to add a rotary end effector to make it easier to actuate spigots to a specified angle. Telling the end effector to move via arc commands has proved very difficult in our programming. Special thanks to those on the right, and thank you guys so much for watching.
Oh my god.